To start lesson 1 of unit 9, I showed how we could fill in the unit circle specifically to the degree and equivalent radian measurements. And so I showed how this 30-degree measurement could be used by 30, 60, 90, 120, 150, 180, and so on. What we did not touch on is these outside ordered pairs. So before I begin with graphing sine and cosine functions for this unit, I'm going to take a second and I'm going to look at what would be equivalent to if we looked at a compass at the north, south, east, and west points. So how do I get to this point? From the center of the circle, I'm going to move 1 to the right, and then I'm not going to go up or down. This ordered pair is 1, 0. To get up to the top here, thinking of this like a compass, the north position. From here, I'm not going to move to the left or to the right. I'm simply going to go up 1. At a position on the unit circle equivalent to 1 pi or 180 degrees, I'm going to go 1 to the left, and then I'm not going to go up and down. And to a position on the unit circle that would be equivalent to south on a compass, I'm not going to move to the left or to the right. I'm just going to go straight down. Okay, so I'm going to come back here and I'm going to take this picture of a very simple unit circle. And now this is 1, 0, and negative 1, 0, 0, 1, and 0, negative 1. Remember with our unit circle, this is like my starting line and I'm moving upward. Now, how can this help me in graphing a sine function? These are ordered pairs, and we're accustomed to thinking of them like an x-coordinate and a y-coordinate. In trigonometry, it's going to be the cosine followed by the sine. So the cosine of an angle followed by the sine of an angle. And a lot of students have a hard time remembering what comes first, is it cosine or sine? So two different ways to remember it. One way is alphabetically, C comes before S if we were going to line these up. Another way was taught to me by a student, and they used the acronym CBS, like the cable television CBS station. CBS stands for cosine before sine. So when I look at this position on the unit circle, whether we think of this as 0 degrees or 360 degrees, it lands on the same spot. We could say the cosine is 1 and the sine is 0. At 90 degrees, also known as 1 pi over 2, the cosine is 0 and the sine is 1. And we can do the same for the other 2 points that I have identified. So at 180 degrees, we have a cosine of negative 1 and a sine of 0. And at 270, we have a cosine of 0 and a sine of negative 1. Now, how is that going to help me? So with this particular problem, number 1, remember that we're working with a unit circle. That means the radius of this unit circle is 1. It's 1 unit. So I'm going to start with this is 0. This is this position. And I'm going to rotate it up to 90 degrees. So at 0, remember, we're working here with sine. So maybe it would be helpful for me to go through and circle all of the signs so they stand out for me. So one revolution, one time around, is going to go 0, 1, 0, negative 1, and I stop back at 0. That's one revolution for sine. So at this position, I'm at 0. Then I move 1 to the right, and I'm up to 1. And so I'm going to show 1 as being right here. This is 1. Okay, then I moved another time, I'm back to 0. I move again, I'm at negative 1. And I add one revolution, one time around the circle, ends at 0. This is a sine curve. Now, sine curves repeat themselves. It's continuously repeating. This is the length of 2 pi. Remember, one cycle around is a distance of 2 pi. As a reminder, whether we're counting by 6s or 4s, we end at 12 pi over 6 or 8 pi over 4. Both are equivalent to 2 pi or 360 degrees, depending if we're talking in terms of radians or degrees. So this is 2 pi, and then I just continue. So I'm at 0, I go 1, 0, negative 1, 0. Okay, I'm at 0, 1, 0, negative 1, 0. So I've done 2 cycles to the right. This length right here is a distance of 2 pi, and I have another distance of 2 pi. 2 pi plus 2 pi is 4 pi. Now I'm going to go in the opposite direction. And so I'm just following this opposite. So I was here. Now at this position, I'm going to reverse and go to the left. So I'm going to go negative 1. I'm at 0 right now. I'm going to go negative 1, 0, 1, and 0. And I've completed going to the left. I just ran out of ink with this pen. Give me 1 second to grab another one. So I've done 2 pi to the left as we show us going to the left. Remember, we're going opposite. So clockwise is like a negative. So this is 4 pi to the right and negative 2 pi as I moved to the left. A period length, also known as a period, means for us to do one cycle, what is this distance? And this distance would be 2 pi. A unit circle for both cosine and sine is a distance of 2 pi. Now, algebraically, a way we can also achieve this is by taking 2 pi and dividing it by the number in front of the x. In this case, it's a 1. 2 pi divided by 1 is simply 2 pi. Let me put pause here and find another pen quickly. All right, hopefully this pen works. So if I take 2 pi and I always divide it by the number in front of the x as a hidden 1, I reduce it, so I still end up with 2 pi. This represents the length of one cycle of a sine curve. Now the x scale means when I break this apart, I want you to think of this as like steps. There's a 4 count here. So 4 count, 1, 2, 3, 4. I finish the cycle, so I'm starting here. Step 1, 2, 3, 4. And regardless of the shape of our sine curve, whether it gets larger or it goes further down, or we take it and shift it, we will always have a 4 count for sine curves. 1, 2, 3, 4. 1, 2, 3, 4. All right, so how do I figure out the length of each one of these 4 counts? It's going to be equivalent. So this length is equivalent to this length, it's equivalent to this length. They're all equivalent. Each of these steps is the same length on the x-axis as you think of it. Here we're going to take the period length, also known as just period, and I'm going to divide it by 4. So we know one of these cycles is 2 pi. Now I'm going to divide that by 4. So 2 pi divided by 4, I reduce it to get 1 pi over 2. That means this length is pi over 2, or 1 pi over 2. This is 1 pi over 2, 1 pi over 2, and 1 pi over 2. Now I'm a visual learner, and so it makes a little more sense to me to actually look at the unit circle. So if I'm able to zoom out here, we have 1 revolution, and it's saying by doing this math that each of these 4 parts, so remember 4 steps, 1, 2, 3, 4. 4 equal steps, and each step is equivalent to 1 pi over 2. So that is a distance of 1 pi over 2. Remember, it's also equal to 90 degrees. A lot of students, when they first learn trigonometry, prefer to use degrees because it's just easier to work with. It's a number. We're not working with adding and radians. But most often when we are graphing, we will revert back to using radian measurements instead of degrees. But anyways, the first step is 90, 90 and 90. Our second step is 180. Add a 90 to get 270. Add a 90, we come up with 360. So step 1, step 2, step 3, and step 4. Let's look at number 2. Like number 1, we are going to sketch the function y equals 3 times the sine of x, and we're going to sketch 3 periods. So here's 1, 2, and 3 from number 1, and then we will list what is the period length, also known as the period, what is the x scale, so the distance for each one of the steps, and then we'll do the maximum minimum that we can see on this particular graph. All right, let me cover up number 1 so we're focused just on number 2. Well, what happens when we see a number in front of the function? What that does is it elongates the graph. So if we go back to this previous graph, so it's visible for us to see, all it does when we have a number in front is it takes whatever the output was. So the output here, when we're talking about a sine function, as a reminder, it's cosine before sine. So I'm looking for the second number, and I'm going to circle that second number, 0, 1, 0, negative 1. All it does is it takes that output, 0, 1, 0, negative 1, and we're going to take it times 3. So I'm going to start at 0. When I take 3 times 0, I still get 0. Now, my next step would be go up 1 because it's positive. But 3 times 1 is 3, so I'm going to go up 3. Now step 2 is right here. 0 times 3 is still 0. So here again, we're starting here. This is starting position. Starting position is at 0. Step 1 is not 1. 1 times 3 is 3. Step 2 is 0. 3 times 0 is 0. Step number 3 is 3 times negative 1 is negative 3. And then my final step 4, 0 times 3 is 0. So what I've done is I've just stretched it. I've stretched it. The midline, which is going to be able to, if I could take a scissors and cut right along this dark line that we think of as the x-axis, we would see that the distance here from the highest or the lowest point is still a distance of 1 back to the midline. That's called the amplitude. So the amplitude here is 3. Amplitude is always thought of as like an absolute value. It's a distance, is always positive. So it's a distance of 3, whether I go up or I go down, it's still a distance of 3 units. This is one cycle. Let's do the cycle again. So I'm at 0. I'm going to go up 3, back to 0, down 3, back to 0. So we have this wave function. So I've done 2 cycles to the right. Now let's talk about what is the period length. So how long is one cycle of this? I'm going to take 2 pi. I'm going to divide it by the number in front of the x. There is no number there because it's a hidden 1. 2 pi divided by 1 is still 2 pi. So one cycle is 2 pi. 2 pi and 2 pi is a distance of 4 pi. As we move to the right, it's positive. Remember, when we go backwards on the unit circles, when we have a negative sign. So it's going to be 2 pi the opposite way, and I'm just going to follow the curve. Down, up, down. So I'm going to go down 3, back, up 3, and back. And this is going to be a negative 2 pi. Okay, so I've done the minimum for this graph as a negative 2 pi that we can see from this position, a positive 4 pi to the right. And now let's talk about the x scale. What is the distance of each one of these steps along what we think of as the x-axis? I take the period length and I divide it by 4. 2 pi divided by 4 reduces down to 1 pi over 2. This is the distance of 1 pi over 2, 1 pi over 2, 1 pi over 2. Let's take a look at number 3. So for number 3, we have a negative 5 over 2. Negative 5 over 2, by the way, is equivalent. Well, half of 5 is 2.5. So what happens when the number out front is a negative? It's still going to be stretched because it's greater than 1. When this value is greater than 1, it's going to be stretched. What does it look like when it's stretched? Well, if we take a look back at problems 1 and 2, stretch is going to be greater. So it's going to be a greater distance from the midline. So it's higher or lower from the midline. If it was compressed, it'd be a shallow dip and rise from the midline. Now, how can we make that prediction? When the number in front of the function, in this case 5 halves, and number 2 is 3, and it doesn't matter if it's positive or negative. When this value is greater than 1, it's going to be stretched. It's going to make a higher rise and a lower dip. When the number is between 0 and 1, so it's less than 1 but greater than 0, that's when we're going to see a more shallow rise and dip. All right, let's get started. So I'm starting right here, and I'm working with just signs, so I'm going to circle my signs. I'm starting at 0. 0 times negative 2.5, that's still 0. Now step 1, instead of going up 1, 1 times negative 2.5 is negative 2.5. Okay, step 2 is at 0. 0 times negative 2.5 is still 0. Step number 3, negative 2.5 times negative 1, a negative times a negative is a positive 2.5. And step 4, 0 times negative 2.5 is still 0. So we've reversed directions. Sometimes students who are having a hard time remembering this, I tell them when we first start learning about signs, think of it generally as you make a hill and then a valley. That's one cycle, hill, valley. Well, why do we switch it up and do valley first and then hill? Because of the negative sign out front. That's what changed it. So this is one cycle. I'm just going to keep going. Down 2.5, up 2.5. So, and here's my second cycle. Each cycle is still only 2 pi. So 2 pi and 2 pi is a total of 4 pi to the right. And I'm just going to continue the pattern. And negative 2 pi to the left. Now the period length, we're going to take 2 pi and divide it by the number in front of the x, which is a 1, still end up with 2 pi. And the scale length, when we divide this by 4, we get 2 pi over 4, which reduces to 1 pi over 2, or pi over 2. That means that each one of these lengths for a step along this horizontal axis is a distance of 1 pi over 2. Okay, let's look at number 4. Now, what changes about number 4 is the number in front of the x is no longer a hidden 1. So let's start by graphing this. I'm going back to the circle. There's no number in front other than a 1, so when I multiply 1 times each of these values, it doesn't change. I'm starting here at 0, and then my next step is up 1, back to 0, down to -1, and back again. This is one cycle. Let's continue that for a second cycle, following that pattern. What I can't do is automatically put 4 pi like I did for 1, 2, and 3. Let's continue the cycle off to the left. And now let's figure out what is the length of one cycle for this function. To do that, I'm going to come up here to the very top, and I'm going to take 2 pi, and I'm always going to divide it by the number in front of the x. So this is one cycle. A period length, or abbreviated just period, is 2 pi over 3. So to go 0, 1, 0, -1, 0 is a distance of 2 pi over 3. Now I have 2 of these cycles, so I want 2 of these. I have 2 choices. I can go 2 pi over 3 plus 2 pi over 3. I add the tops to get 4 pi over 3. That's one option. So this is, or I simply could have taken this times 2 because I have 2 of those. And I end up still with 4 pi over 3. So either add these together or taking it simply times 2, you end up with 4 pi over 3. And then we did one revolution to the left, -2 pi over 3. All right, now let's come up here. Each one of these steps is how far. So if it's 2 pi over 3, and we have 4 steps, 1, 2, 3, 4, 4 steps, what is the distance of each step along the horizontal axis? We're going to take this value, 2 pi over 3, and I'm going to divide it by 4. Now, when you divide fractions, remember, you keep the first number, you turn division into multiplying, and you take the reciprocal of the second number. So I end up with 2 pi times 1 is 2 pi, 3 times 4 is 12, and 2 pi over 12 is correct, but this can be reduced to 1 pi over 6. So this is a distance of 1 pi over 6, 1 pi over 6, 1 pi over 6, and so on. Let's take a look at number 5. Number 5 is going to incorporate what we learned from problems 1, 2, and 3 when we have a value outside and when we have a number in front of the x. I'm going to rewrite this just as a reminder. This is the same as y equals 2 times the sine of 1/2 x, just written in a different way. All right, so let's get started here. I can see that I still have circled my signs, so I'm starting at 0. And 2, the number outside, is going to impact the amplitude. So 2 times 0 is still 0. Now step 1, 1 times 2 is 2. Step 2, 0 times 2 is 0. Step 3, -1 times 2 is -2. And ending on step 4, 0 times 2 is 0. So I have one cycle done, and now I can just repeat that to create this graph. Okay, now let's come above and let's figure out what is the length of one cycle. So if I just stop right here, what is this length of one cycle or 4 steps? Starting 1, 2, 3, 4, what is the length of this cycle? I'm going to take 2 pi and I'm going to divide it by whatever is in front of the x, which is a value of 1/2. Now I prefer when I divide these to write it horizontally. So 2 pi over 1 divided by 1/2. Division turns to multiplying. I'm going to keep the first number in place, and I'm going to take the reciprocal of the second number. 2 pi over 1 times 2 over 1 gives us a value of 4 pi. So from here to here is a distance of 4 pi. Now the x scale, which represents each one of this lengths along the horizontal axis, I divide this number by 4, and 4 pi over 4 reduces simply to 1 pi. So this is the distance of 1 pi, 1 pi, 1 pi. So if one cycle is 4 pi, and I did 2 cycles from the origin to the right, 4 pi plus 4 pi is a distance of 8 pi. Now when I go to the left, remember it's going to be a negative. One cycle to the left is negative 4 pi. Let's take a look at number 6. Let's take a look at number 6. Okay, number 6, I'm going to start by knowing that I begin at the origin for a sine function. I start with 0 times negative 3 is still 0. Now when this value is negative, instead of doing hill for step 1 and 2 and valley for step 3 and 4, I'm going to reverse it. And you can see that as we multiply. So here's 0 times negative 3. Now 1 times negative 3 gives us an answer of negative 3. 0 times negative 3. Step 3, negative 3 times negative 1 is positive 3. And 0 times negative 3 as we complete the cycle. So we have an amplitude of 3 because the distance from the highest point back to the center line, called the midline, or the lowest point back to this midline is a distance of 3. I'm going to continue with one more cycle, down and up. And I'll do one cycle to the left. All right, now let's figure out the period length. So I'm going to take 2 pi, I'm going to divide it by the value in front of the x. The pi's don't disappear. They are going to simplify to 1, and I have 2 times 1 is simply 2. So one cycle is 2. So here's 2, and here's 2 for a value of 4, and I did one cycle to the left for a value of negative 2. Now to find the x scale, or the distance, for each one of the 4 steps, we're going to take this value and divide it by 4, which gives us an x scale of 1/2. So 1/2, 1/2, 1/2, 1/2, and so on. All right, so now we're adding in a new component of graphing this function. This value, remember, is going to impact the amplitude, or the distance that we go above or below the midline. The number in front of the x will impact the length of one cycle, which means it'll impact the x scale, or what is the distance on the horizontal axis as we go from step 1 to step 2 to step 3 and step 4. Now, what about this last number? This is going to impact what our midline is. So now I'm going to go up 1, and I'm going to pretend like this would be our previous x-axis. So think of this as now being, this point right here is now being the previous origin. This is our origin. We're still working with sine. Remember, it's CBS, cosine before sine. So I've taken care of this one. It's a vertical shift. I don't want to worry about it, so I've crossed it out. And now I'm going to worry about the amplitude. 0 times 2 is 0. 1 times 2 is 2. 0 times 2 is 0. Step 3, negative 1 times 2 is negative 2. And step 4, to complete the first cycle, 0 times 2 is 0. This is one cycle. I've shifted it up 1, that's our new midline. And now the amplitude is 2. The distance from the highest or the lowest point from the midline is a distance of 2. Let's continue with cycles to the right and to the left. Okay, now let's figure out what is the period length, also known as the period. I'm going to take 2 pi, I'm going to divide it by whatever is directly in front of the x, which is a 2. 2's are going to reduce down to 1, and I'm left with the distance of pi. So one cycle is pi. So I have 2 cycles to the right, so pi plus pi is 2 pi. And I have 1 cycle to the left. As we move to the left, it would be a negative pi. Now, the x scale would be, what is the distance along the horizontal axis for each one of these steps? We're going to take the length of the period and divide it by 4. This is a distance of pi over 4, pi over 4, pi over 4, and so on. Let's take a look at number 8. I'm going to start by rewriting this function. I'm going to do it down here where I have a little bit more space. Let me zoom out here. A little more space. Maybe I even have room here. So I have y equals negative, now 3 over 2, by the way, is the same as negative 1.5. You could leave it as a fraction. It's just going to be helpful for me to turn it into a decimal. And then I have the sign. Now, when it's just basically over 3, that's the same as 1/3 x minus 2. So I've just rewritten this function. Where do I start? I always start by first identifying any vertical shifts. And if we see those, they will be not attached to the function itself. They could be in back or they could be out in front. It could be like -2 plus this quantity. So I'm going to go down to -2 and I'm going to identify the vertical shift. And then personally, I'm going to come up here and I'm going to cross it out so I don't have to worry about that piece anymore. With any signed function, we always do hill, that's step 1, 2, and then valley, step 3, 4. But when the value out front is negative, we reverse it. So instead of going hill and then valley, it will be valley and then hill. Sorry, distraction of kids. I press pause. I got to think where we left off with this part. So I can see that I've shifted it down 2. And now I'm going to start again. So I think what I was saying before I had put it on pause when Benny was coming into the room is that our sign function generally will go hill and then valley. But when we have a negative sign out front, we're just going to reverse it. And you can see that here as we multiply. So -3/2, which is the same as -1.5. You could plug this into your calculator to see that. I'm going to take -1.5 times 0. I still get 0, but I'm not going to do it here. I'm going to do it where my new origin is. Then I'm going to take 1 times -1.5. And I'm going to take step 2. So here's starting, step 1, step 2. 0 times -1.5. Step 3, -1 times -1.5 is a positive 1.5. And step 4, 0 times -1.5 is back to 0. So I did the valley first and then a hill, and I'm going to continue that. And doing it back over here. We have 1.5 up, 1.5 down. All right. So I've taken care of graphing this. Now I'm going to start with what is the length of one cycle here. So I'm going to take 2 pi and I'm going to divide it by 1/3. So divided by 1/3, I keep 2 pi the same. I turn division into multiplying, and I multiply by the reciprocal. If I could move this down, you'd have a better chance of seeing that. So when I multiply across, I have 2 pi times 3 is 6 pi over 1. It's the same as 6 pi. You could put 6 pi over 1 if you wanted to. Now I'm going to take this, and I'm going to divide it by 4. So 6 pi over 4 is fine, but that does reduce down to 3 pi over 2. What does this mean? So it's 6 pi's just to do one cycle. This is the length of one period of 4 steps. Starts here. Step 1, 2, 3, 4. That's 6 pi. So 6 pi and 6 pi is 12 pi going to the right. And then remember, as we go and reverse it, it's one cycle to the left represented by a negative. Now each one of these steps is equivalent to 3/2 pi or 3 pi over 2 or 1.5 pi. Let's look down below.